Okay, let's start 12.4, adding and subtracting polynomials. And we'll just get right into doing some examples. This is best learned by example. So here, in each parenthetical grouping, we have two polynomials and they're being added. So when they're being added, all we have to do is just collect like terms and simplify. So we have 9x to the fourth minus 3x squared, that's in parentheses, plus 9x to the fourth plus 7x squared. So when the operation is addition, literally all we have to do is just remove the parentheses, and you don't even really have to do that, and collect like terms. So again, starting with my x to the fourth term, I'll repeat it down here, 9x to the fourth. Now I'm going to look for another x to the fourth term, and I found one right here. So I'm going to put it right next to my other x to the fourth term. So I'm basically collecting terms according to their power. Now I can go in order of the terms as they appear from left to right, or I can go in order of the power or degree of the term. In this case, they're identical. There will be cases where they are not. And these are like terms, and these are like terms, so I just add the coefficient on the term and attach the variable term with its power. Minus 3 plus 7 is the same as 7 minus 3, so that's 4x squared. So let's go ahead and do one B. So here I'm going to have 2x squared minus 2x plus 3. So that's polynomial 1. And the next is polynomial 2 in parentheses. So again, the operation between, this is polynomial 1, this is polynomial 2, the operation is plus addition. So I'm not going to bother to do anything here other than start with the largest degree term and write it down below. I like to cross it out to make sure that I get them all. Then I look at the other degree 2 term, which is 4x squared. Now I'm going to look for degree 1 terms. So there's a minus 2x term, and there's a minus 4x term over there. And then I have a plus 3 and a plus 7. So these are like terms, these are like terms, and these are like terms. So I just add the coefficients. And because, oh wait, sorry, that's not right. That's 2 minus 4, not 2 plus 4. So let's change that. So 2 minus 4 is minus 2. Minus 2x minus 4x is minus 6x. And 3 plus 7 is plus 10. So let's continue on. So again, these also are just adding of polynomials. So 1c, we're just adding. I have 5x cubed minus 3x plus 7 plus that's the thing you want to focus in on, is that I'm actually adding these polynomials. So here's the second polynomial. So I start out with the highest degree term, which is a degree 3 term. That's supposed to be 4x cubed. And I've copied it down, and I find, is there any other degree 3 terms? And there is. So it's plus 4x cubed. Now I look for my degree 2 term, and right there it is, minus 2x squared. Now I look for degree 1 terms. Right there is plus 10x, and there is a minus 3x, and then I have a plus 7. The reason I cross them out is sometimes when you copy them down, you'll forget to copy down a term. So by crossing them out, I can quickly glance up there and say, oh, I've got them all. So these are like terms. This is a like term. These are like terms. And this is, so the minus 2x squared and the plus 7 are the only terms of that degree. So 5x cubed plus 4x cubed is 9x cubed. Then minus 2x squared, there's nothing to simplify there. 10x minus 3x is plus 7x. Then I have plus 7. Let me check the 10x term. Plus 10x minus 3x. Okay, that looks good to me. Okay, let's do another one. There we go. This is 1D. So 7 into the 6th minus 5 into the 5th plus 9n plus 9 into the 6th minus 5 into the 5th plus 2n. So let's start with the degree 6 terms. So that's 7 into the 6th plus 9 into the 6th. The next degree term is degree 5 term. Minus 5 into the 5th minus 5 into the 5th. So that gets this one and this one. And now I have degree 1 terms, plus 9n plus 2n. So these are like terms, these are like terms, these are like terms, so I combine them. 7 plus 9 is 16. So that's 16 into the 6th power. Minus 5 is minus 10. Attach it to the variable, raised to its power. 9 plus 2 is 11. In. Okay, so the next one we're going to do is going to contain some subtractions. So I've got to talk to you about how to do subtractions. They're really easy, but you have to be careful. So let's just do 2a. So in this case, we have 3x minus 8. And here, my main operation is minus 5x plus 17. So we're going to transform this part right here. And I'm going to rewrite it as a completely different polynomial. So I'm going to rewrite this as 3x minus 8 plus some polynomial. And then once I convert the minus to a plus, then I can do just what I was doing in the first 4 exercises. So here's how it's going to go. And there's a lot of ways to do this. I'm going to change this to a plus. Then I'm going to write my parentheses there. And the price I have to pay is, I just ignore this minus right here. I just changed it to a plus. So the price you pay is you have to work on what's inside the parentheses. Each term inside the parentheses has to change its sign. So now I'm just ready to add those. So that's the degree 1 term, 3x minus 5x. And the degree 0 term, minus 8 minus 17. Combine like terms. 3 minus 5 is minus 2, and attach the variable along with its power. And minus 8 minus 17 is minus, not 15, but sorry, minus 25. So that's our final answer right there. Okay, for the next one. Let's do 2b. So I have 4x cubed plus 9 minus 8x cubed minus 13. So what I'm going to do is change this into the addition of 2 polynomials. So I'm going to change my minus sign to a plus sign. Now I have to pay the price. The price is, I literally just focus on what's in parentheses in the top line, and I change the sign. So minus 8x cubed becomes 8x cubed, and minus 13 becomes plus 13. Now I'm ready to add. Now that's supposed to be a cubed. So now I'm ready to add. So starting with my degree 3 term, and then my constant terms. So 4 plus 8 is 12, so that's 12x cubed, and 9 plus 13 is 22. Oops, wrong one. I'll eventually get it right. So this is 2c. So we have 3 to the 7th power minus 11 to the 5th power minus 15 minus 6 to the 5th power plus 9 to the 7th power minus 13. So again, the first thing I do is I just change this into an addition problem. So I change the minus sign into a plus. Then I write my parentheses down, and I look at what is in the parentheses on my first line, and I change the sign of each term. So minus 6 to the 5th becomes plus 6 to the 5th. Plus 9 to the 7th becomes minus 9 to the 7th. And minus 13 becomes plus 13. So now I start by collecting like terms, starting with the highest degree term, which is the degree 7 terms. So that's 9 to the 7th. minus 9 into the 7th. Now degree 5 terms, minus 11 into the 5th, plus 6 into the 5th, minus 15 plus 13. So these are like terms, these are like terms, and so are these. So 3 into the 7th minus 9 into the 7th. Well, 3 minus 9 is minus 6. And then I attach the variable and its power. Minus 11 plus 6 is minus 5. And I attach the variable n to its power. And minus 15 plus 13 is minus 2. And right there is our final answer. Well, I didn't change the color, but we can live. Minus 6 into the 7th, minus 5 into the 5th, minus 2. So the next one is indeed one that deals with fractions. And we're going to do it. I would much rather do one with fractions than one with decimals, although decimals are actually easier. So this is 2D. So nothing changes until we get to the addition phase. So we have 3/4 x squared, minus 7/8 x plus 4/5. So the coefficient of the x squared term is 3/4. The coefficient of the x term is minus 7/8. And the constant term here is plus 4/5. So again, I just recopy down. The first polynomial doesn't change at all, but I'm going to change the minus sign to a plus, and as a consequence, I'm going to change the sign of every term in my first line, what's in parentheses. So that becomes minus 1/6 x squared. This becomes plus 1/4 x, and this becomes minus 7/10. Now I'm going to collect like terms. I'm going to give myself some more room. So x squared terms first. 3/4 x squared minus 1/6 x squared. So I just took care of the x squared terms. Now let's do the degree 1 terms. Minus 7/8 x plus 1/4 x. So I took care of those two. And my constant terms, plus 4/5 minus 7/10. So here is the thing. All we need to do is combine like terms. There, we do not need to find the LCD of 4, 6, 8, 5, and 10. So all of this does not have to be over a common denominator. All we do is we find the LCD of our like terms. So the LCD of 4 and 6 is equal to 12. The LCD of 8 and 4 is equal to 8. Why? Because 4 divides 8. And the LCD of 5 and 10 is equal to 10. So here's how we're going to proceed. Now, if you wanted to, I'm not going to do it that way, but if you wanted to, you could come over here for our degree 2 terms, And you could write 3/4 x squared minus 1/6 x squared is equal to something over 12 is equal to something over 12. Why 12? Because that's my LCD. So 12 divided by 6 is 2. 2 times minus 1 times x squared is minus 2x squared. 12 divided by 4 is 3. 3 times 3x squared is 9x squared. And the sum here is over 12, so I get 9x squared minus 2x squared, so that's equal to 7x squared over 12. And you could literally do that for each one of these groupings. But over here, I'm just going to add my plus here. My LCD is 8. So minus 7/8 x is minus 7x. So 8 divided by 4 is 2. 2 times 1x is plus 2x. Over here, I'm going to add a plus. My LCD is 10. 10 divided by 5 is 2. 2 times 4 is 8. 10 divided by 10 is 1. 1 times minus 7 is minus 7. Now I'm ready to combine everything. I actually already did the first term. So this is 7. You can write it as 7x squared divided by 12 or 7/12 x squared. It doesn't matter. This is minus 7x plus 2x. So this is minus 5x over 8. And this is 8 minus 7 over 1. So that's 1/10. And if you don't want the x right there, you are absolutely free to move it right here. But that's a crutch that I want you to get rid of as soon as you can. And you can do the following. Take the minus away from the 5 and put it right here. But those are crutches that you need to start getting rid of, because when we move on to more advanced classes, we're just going to say, okay, you've had time to figure it out, and we're going to go. So let's go back up to our page. There we go. So let's do number 3A and B and then C, and that's it for adding and subtracting. So adding and subtracting aren't really that difficult. The only thing you ever really have to be careful with is subtraction and collecting like terms and copying down everything that's on the previous line. So this is 3A. So I have 4n to the 6th plus 5n plus 2n cubed. So notice this polynomial is not written in the order of descending powers. That's okay. That's it's not required. So again, this is plus. So I'm ready to go. So this is 4n to the 6th. So I'm looking for my degree 6 term, and right here it is. Done. And that's all of my degree 6 terms. Now I'm going to do my degree 3 terms. I'm going to write them in descending powers. You don't have to. I'm having a feeling my math lab will require you to. And it sure does help in grading, I will tell you that. I usually don't require my students to do that because, well, the answer is mathematically correct, and I don't like making students do things an extra step that will change something from something which is mathematically correct to something which may not be because you've added an extra step and made an extra error. But now we actually can choose to do it in descending order by our choice of adding. So, copying down on the next line. So 4n to the 6 plus 4n to the 6. 4 plus 4 is 8. 2 minus 9 is minus 7 n cubed. So this is a polynomial in the variable n. And 5 minus 8 is minus 3n. And that's our answer. The next thing we're going to do is the decimal one. It's not so hard. And you'll find it's easier than the fraction one. So this is 3b. I'm more okay with doing decimals here because really adding and subtracting polynomials is not difficult. However, we consistently see the errors occurring in the subtraction part. So I would suggest until you get really good at doing this and feel really confident for what you're doing, that you go ahead and do it the way I'm doing it right now until you feel really comfortable with your skills. So what is the way we're doing it? We're changing it into an addition problem, and then we're just adding. So this is 0.3. I want to see the original. I kind of like to see the original when I'm copying it down to make sure I haven't changed anything. So 0.3 z to the 7th power. That's going to be a z to the 7th power plus 1.1 z to the 5th power minus 15. I'm going to change this to a plus. Then the price I pay is the signs of each one of these individual terms change. So minus 6z to the 5th becomes 6z to the 5th plus 9z to the 7th turns into minus 9z to the 7th. And plus 13 becomes minus 13. So now let's collect like terms. We're going to collect the z to the 7th terms first. That's the degree 7 terms. Then we're going to go the degree 5 terms. And then the constant terms. So these are like terms, these are like terms, and these are like terms. So 0.3 minus 9. So minus 9 plus 0.3 is the same as, I'm going to change the signs, and then I'm going to negate my answer. So 9 minus 0.3, 8, 10, 7, 8.7. And since I changed those signs, I'm going to change my answer. So that's minus 8.7 z to the 7th. 1.1 plus 6, that's easy. That's 7.1 z to the 5th. And minus 15 minus 13, was the original plus. Yep. Minus, and that's a minus. That's a minus 28. Okay, and that is my answer. Right here. And we have one last problem to do. So here, the only issue, and it's a common issue, is the meaning of subtract this from that. So subtract, let's just take subtract 7 from the sum of 10 and 4. So what I've done here is I've replaced the polynomials and I've replaced them with something else. So this is the same as taking 10 and adding 4 and subtracting 7. And that's really easy. The answer is going to be 14 minus 7, which is 7. So we're going to do the same exact principle here. So whenever you see something similar to this, you should make sure that you understand what to do. So what we're going to do, let me get back to my yellow, is I'm going to add together two polynomials. 5a to the 5th minus 5a to the 5th. No, that's to the 2nd. And then I'm adding 3a to the 5th minus 7a squared. And then I'm subtracting 3a to the 5th minus 4a squared. So PEMDAS is in play here. And we can indeed simplify what is in parentheses. So parentheses include this type of parentheses, which I think are just called regular parentheses, and brackets. These together are just called grouping symbols. So I'm going to do what's in the grouping symbols first. And it's addition, so it's not going to be so bad. So I'm just going to group together the degree 5 elements. And then the degree 2 elements. And then over here, I'm going to be lazy and I'm just going to put minus ditto. I'll copy that down again when I have to. So I'm going to simplify this over here. And if you want to turn those, if you wanted to, instead of writing brackets, you could have written something like this. And just use two types of parentheses, where this is my polynomial here, and this is a plus. And this is my polynomial here. It doesn't matter. Grouping symbols are grouping symbols. So let's simplify this part. So this is going to be 5a to the 5th plus 3a to the 5th is 8a to the 5th minus 5a squared minus 7a squared is minus 12a squared. See, I actually just wanted to write a parentheses rather than a bracket. I'm far more used to writing parentheses than brackets, but that's okay. And then I'm going to subtract this. So I'm back up to here. So I'm going to change the minus to a plus, and then change the sign of each of the terms in the parentheses on the top line. And now I'm ready to just group them by like terms. So I'm going to start with the degree 5 term. And then move to the degree 2 term. These are like terms, and these are like terms. So the end result is going to be 8a to the 5th minus 3a to the 5th is 5a to the 5th. Minus 12a squared plus 4a squared is minus 8a squared. And that's our final answer. Okay, that's it for lecture 12.4.